continue with our discussion on OCL. So anyone still remember what OCL stands for? So object constraint language. Okay, that's cool. Nice. Alright, so OCL, if you still remember, I think after a weekend maybe you almost forget 60%. Hopefully still have 40% in your mind, but let's see. Come on. Okay, OCL. That is the object constraint language, which we use as a extension to our UML, to our traditional modeling, because those traditional modeling language, unified model language, most of the time they do have their expertise in some of the modeling, but they cannot just represent the whole set. They cannot just simply easily convey the all the specifications to the other stakeholders or to the system. So that's why we have this OCL, which is the following the idea of modeling driven architecture. Okay. Very brief review. So yeah, just think of something. So we have context, right? Context basically specify like something like your standpoint, your viewpoint. Then from that context, you can like putting on this invariants there. Like we specify the size less or equal to 6, like this one, right? And another thing I want you to still, okay, let's look at this example here. So a pilot is a member of the crew, and all flight attendants are also crew members. Okay, so we are in the context of flight. And then we have 3 different relationships. R1 will be the relation of a pilot. R2 is crew member. R3 is the attendant. Therefore, we know like self R1 includes self R2 is the a member crew member includes pilot, and also here R1 includes or self R3 because R3 is also a set, so we use includes or instead of includes. So that means crew members includes all the members of attendants. Okay, no problem with that, right? Right? Give me some kind of feedback. Yeah, okay. So that's basically OCL. And also we can use the many predefined types, remember? Integer, right? String, just like that. And for some of them we have this method, like string has a concat, so it connects different strings, something like that. Also here, this thing maybe you might remember, right? Forgot. So this is what we want to see. That context is in the account, and self.r1 for all E1, E2, which is customer. So E1 equals E2 implies E1 ID equals E2 ID. So that basically kind of predicates to make sure that everyone has their own ID. Okay, everyone has their own ID. All right, remember this. Maybe you may forgot about it, but we this is a predicates which returns true or false. So we can use that in the OCL as well. Okay, let's skip to the end. Hopefully you still remember everything. Okay, so this is a case study we're doing. Let's try this one. Okay. Alright, this one. A person may have a mortgage on a house only if that house is owned by himself. Have we do this last time?
Yes.
Okay, let's do this one. The social security number of all persons must be unique. Okay, then use the house as context. Remember this? The social security number SSN for all persons must be unique. And then we use the house as a context. Okay, let's do this. Social security number should be unique. We use the house as a context. Okay, so what we do is context as a house, right? Invariant. So that's a problem. How can we do that? So yeah, I actually just repeat that part, right? No one knows. Self-dart R1.
And then the arrow.
Let me give you a hint. We just take a look. Yeah. Here, to this one, we do something pretty similar to this.
For all.
Yeah. Let me just copy paste. Okay. So with self.r1, which goes to all the person.
This is for all. Use social.
E1, E2, which is a person, right?
Yeah.
Person. So E1, E2 implies E1 dot ID.
When you use the
social security number, right? What? Can you see that? Yeah. Dot social security number. Okay, the other one, a new mortgage will be allowed only when the person's income is sufficient. How can we define this sufficient? Let's assume that the yearly payment must be less than 30% of the salary. Let me copy paste this here. Okay, let me read it again. So, okay, a new mortgage will be allowed only when the person's income is sufficient. Assume that the yearly payment must be less than 30% of the salary. Let's select a context first. So let's see. We want to do something with the mortgage, right? Mortgage, and only be allowed when the person's income is sufficient. So yeah, what is appropriate context? Let's see. Let's try. Can we do the house? Maybe we can do house, because house we can relate to the person. But here we're saying the mortgage will be allowed. It looks like the person is trying to get a mortgage. Then we're triggering something. We justify if that's allowed, right? So there is an option. This operation in the person called get mortgage, right? Get mortgage. Right, so we will do this person, and we want to get into this operation. Get mortgage and blah blah blah. Some money, security. So basically this is the context. And then what next? What's next?
R3 or R1?
No, not yet. Do we put INV here? What was that?
Make it bigger.
Oh yeah, that's too small, right? Okay, let me use Word.
When you use pre and post?
Okay, it's big enough, right? Cool. So we want to make sure the mortgage is sufficient. The yearly payment less than 30%. So yeah, that's basically a precondition, a precondition of this operation. You agree? Yeah. Because we have to check this condition before you execute this get mortgage, right? When we're doing this get mortgage, we check this first. Right, so it's going to be a precondition. I remember how we define precondition, just pre. And what's next? Okay, let me pour this out. So the person has something, his salary, and the get mortgage has a mortgage like something like this.
You do some.
Do we use some? Because we are trying to use this salary. No, the yearly payment instead of sum. Then I think this person, we do not have enough like, information there, right?
Why
Therefore,
don't we?
We have their salary, presumably.
yeah, we have salary, but how about the yearly payment?
I mean, presumably there is a.
Well, it says it's salary, doesn't it?
Uh,
It says yearly income, and then the yearly payment can be, you can figure that out from mortgage, but I don't think you can figure that out from get mortgage.
yes. The thing is, within this person, we do not have this yearly payment thing. So but in the mortgage, we can find that the yearly payment basically is this monthly payment times 12.
Okay, so we gotta change the context.
Yeah. Let's see. No. Okay. Here. Person, mortgage. Yeah. So we actually don't have to change the context. We can still use a self. Okay. Self dot. Let's see this diagram. R3. Self.R3, and we need to take into consideration, because when we say persons dot R3, they are actually a set, maybe a set of mortgage, right? Maybe a set of mortgage. Okay, so a problem is we need the monthly payment. We calculate the yearly payment from the monthly payment, and there are a whole bunch of those mortgage there, right? Right. So we R3. Yeah, we actually did this R3. If you remember, with R3 we can still dot monthly payment. So that's basically a set, right? And if you remember, we have a function called sum. Let me pour this out for you.
Why would monthly payment be a set? Presumably it'll be the same amount every time, so it wouldn't just be an integer value essentially? Or
What?
A single value?
You mean the monthly payment?
Yeah, why would it be a set?
So that's a one-to-many relations. Right? If you have two houses, you want to make sure if you have two mortgages on two houses, still the bank is going to check if like for example, I pay 1,000 for this house, I pay another 1,000 for that house. If I own 100 house, it will be like 100K every month. That basically is above the 30%.
I mean, the criteria provided in the setup did not reference anything other than external mortgage. It said if you want to open a new mortgage, that mortgage's monthly payment can't be more than 30% of your monthly income.
Only when the
yearly
person's
payment or whatever.
income is sufficient. Assume that the yearly payment must be less. It just say a yearly payment, but it doesn't say it's a yearly payment of that new mortgage. And from the common sense, usually bank will check all the mortgages. So I made that assumption there. Yeah. Therefore, we need a sum. Let me pull out this sum for you. The sum is basically a function here in the collection. I don't know if I say something about that here. string collection type. Okay, it's here. Okay, it's not specified here, but okay, I think there should be a function called sum. Okay, it is actually maybe I put that in this specification, but there is a function for the collection called sum, which sums them up, and then the sum. Let me see. Times 12 should be less or equal to the let's see, this salary times 0.3, 30%, right? Is that 30%? 30%. Okay. Yeah, the last one. A new mortgage will be allowed only when the customer value of the house is sufficient. Let me put it here. When the house value, counter value of the house is sufficient. Which means if you want $1,000 for a house, the house must worth greater or equal to 1,000. Okay, does that make sense? Right? Okay. So let's try this. Take your pen, try it. Context.
Wouldn't it just be the same context as the previous one?
Let me see.
Because I mean, this is still essentially a precondition on get mortgage.
Yep. Yeah. Let's see. So let's still use this one. Precondition. So the house, actually we have a value, right? We have a house value. And yeah, we can just use this. We don't need R1, R3 at all, because we have this house and the money already there as the input, right? So therefore, we just need to say we just use sum and security. I don't know why it's called security, but it refers to the house you want to buy, okay? And sum is the amount you want to borrow from the bank. Security is the house you want to buy. And we do something to sum and security. That's hard. That's hard. Yeah, maybe you know the answer, you just don't know if that's correct. Right? Because it's simple. We want to make sure that the house worth the value, right? So if the house worth $1,000, okay, a million. If house worth $1 million, you can borrow, maximum you can borrow is $1 million, right? You cannot borrow $1,100,000. So sum is the value. It should be less or equal to security dot value. If we go back here, the house actually has this value here, right? And we're comparing sum of the type money with the value of the type money, right? So that's how we make sure when we get the mortgage, we want to make sure that the house worth that value. Okay? All right. So any questions on this part? Yeah, some of you have this face like confused. I don't. Yeah. So which point is confused? Can you let me know?
So sum is the money that the person has, right?
Sum is the money that the person want to borrow.
Okay.
Yeah.
So okay, so that's the amount of money they want to borrow.
Yeah.
It's also an operation. I think that's where people are getting confused because in the previous one, sum is an operation, but
Yeah, it is an operation. Yes. And this is a precondition of that operation, right?
okay, so the post condition for that. is,
Okay, we're not going to specify a post condition for that. It's not like that. Every operation has pre and post condition. Some operation may not have post condition at all, or may not have precondition at all.
Yeah.
Right? Okay. Good. Now let's go to more complicated OCL stuff. We learned the OCL from a example, okay, in this folder. It's actually the textbook, in the textbook as well, and we have this example, basically the textbook scanned here. Come on, I want to make it smaller. How can I do that? Okay, smaller, smaller. Yeah, I need to okay, zoom. Okay, fine, let me download this one so that open. Okay, this is much better. And we can have this. Okay, can you read the word? Okay, basically let me. Okay, is this better? Okay, you have a computer, right? You can
Yeah.
open that in your computer, on computer. Just put this, okay, this way. Okay, so this is better. Okay, so this is a system. I mean, it's a system built for a fictional company called Royal and Loyal, R&L. So from the name, you know what this company do. It basically manage all those loyalty program for maybe airlines. Basically every store they have this sort of loyalty program, right? Okay, so this is basically a model, a UML diagram for that company. Okay. So for that company, the company manages the loyalty program for different clients. Maybe Delta Airline is one of their clients, United is another clients, and Kroger is another client, something like that. Okay, so basically it's a loyalty program. If you know what loyalty program is, basically it works that way. You spend money, you get those points, and with those points you get sort of benefit, right? And also with the points you may upgrade. You may upgrade your membership to another level. Maybe it's called silver, it's called gold level, golden member, something like that. So that's loyalty program, basically the basic functions of the loyalty program. Okay. So the points can be maybe something like air miles, reduce the rate, something like this. Okay, so this company, suppose this is a company, Royal and Loyal. They have a system that can handle all these different programs, all those different loyalty programs. If you are familiar with loyalty program, if you have this airline points, airline miles, sometimes the Delta miles can be used by some other airlines which belongs to the same league. You know that, right? So that means for all those programs, there are many participants for that program, and those points can be used in any of this program. Okay, remember these facts because that's how this system is modeled. All right, so the center of this class in the model is called the loyalty program. Okay, if you see on the top, the loyalty program here. Where's my mouse? Loyalty program. Okay, so suppose this is a company with this system, and this system is used for different loyalty programs. Okay, so let's assume the company has a lot of servers. Okay, how many instances do they have? How many instances of the loyalty program do they have? It's one or many, just two options, one or many. I mean, for that loyalty program, it's basically the main class of the whole system. Okay, so do you think there are one loyalty program class running on instance on this system for this company, or there are many of them? Yeah, basically let's assume there are many of them because this I say this company, their customers include different organizations, different airlines. Okay, so for each of this program, they are running a loyalty program instance for that. Okay, maybe they're running on different server or maybe different servers as possible. Okay, but for each program, there's only one loyalty program class, not class, loyalty program instance, like the object of that loyalty program. Okay, all right. Right, so let's assume that way. And a company that offers its customers membership in a loyalty program is called a program partner. Okay, that's the second thing here. Program partner. Okay, let's see here. Program partner to the loyalty program is many to many. All right, what does that mean? What does that mean?
Many program partners for many different
Yes.
programs.
Yes, that means there maybe for one loyalty program there may be a bunch of partners. Okay, and for each of the program partners, they may participate in different loyalty program. Okay, so that I mean for this loyalty program like Delta mileage, what's that called? Sky miles. Okay, Sky Miles. The points are in the Sky Miles. So Delta is definitely one of the program partners. Okay. The other, maybe another small airline. Can you give me a name of the airline that is within the same league of?
Southwest.
Yeah, maybe Southwest. Okay, let's assume. Okay, so Southwest is another program partner of that loyalty program. Okay, but meanwhile, maybe Delta can participate in some other loyalty programs as well. So that's many to many. Okay, program partner. However, in this SkyMiles, the partner may include Delta, may include Southwest, and it may include another maybe a gas station. Okay, maybe you can use the Delta points in some gas station. That's possible, if that is a program partner. Okay, so that's a program partner. All right. And every customer of a program partner can enter the loyalty program by filling in a form, obtaining a membership, of course. And the object of class customer represent the persons who have entered the program. So that's the here the customer. Okay, so customer to this program. It's also. It could be many to many, yeah. But a loyalty program will definitely have more than, most of the time you have more than one. It's not one-to-one relation. Okay, and we also have another class called membership card. So that's represented by the customer card. Okay, so the card has different value, like it's whether it's valid, and we have a expiration date. Most of the time, and name, something like that. Yep. It's issued to a person. So let's see. Yeah. So it's issued to a person. But from the customer to the card is one to many, which means a customer can have many cards, right? However, a card cannot belong to different persons. Make sense? Right? The card can only belong to you, your card. Okay, that's good. And then let's see, what else do we have? And yeah, and most of the loyalty program, it allows the customer to save bonus points, and each individual program partner decides when and how many bonus do you give to allocate to the certain purchase. So saved bonus points can be used to buy specific service, or be exchanged for some free service, or purchase tickets. That's all up to the partner. Okay, so but we do have another class called account here, loyalty account here, which here you can see my mouse, loyalty account here, which manage those points. Okay, which manage those points information. And various transactions on this account are possible. For example, the loyalty program has 4 program partners: a supermarket, a gas station, and a car rental service, and an airline. How does that happen? It's like this. So I'm going to read this example. So how can a program be used in different stores? Okay, so at the supermarket, the customer can use bonus points to purchase item, and the customers earn 5 bonus points for any regular purchase over the amount of 25. Okay, and also if you use the same card, same program, the gas station offer a discount of 5% on every purchase. So that means we are not changing the points, the bonus. And then the car rental service offers 20 bonus points for every $100 you spend. So something like that. That's an example. Okay. So customers save those bonus points for free flights with the airline company. For every flight that is paid, the airline offers bonus point for each, maybe 1 miles or 15 miles. So that depends on the company. So that's how it's used in different store, because different store has different rules. If you spend $1 in Delta, maybe it gives you 1 point, but if you spend $1 in a gas station, maybe it only gives you half or something like that. Okay. So that's all depends on the set up by the partner. Okay. Okay. So, but that kind of information, basically, it's missing from this class diagram. Okay, because we only have this partner, we have this account, and partner will maybe do some account, will do some service like points earned, points burned, and they do some operation to the loyalty account. Okay, that's fine. But in this service, there's no place for you to specify the rule, like what I just read. $1 for points. Can you do that in the class diagram? No. We have to do those kind of things in OCL, right? In OCL, with OCL. All right. And there are some other classes here. Okay. And here, if you see under the transaction, there are two subclasses. One is burning, one is earning. So it's easy to understand. So burning transaction is the transaction that you spend money. So you burn the money, okay? And earning transaction. So both earning and burning are the subclass of a transaction. Okay. The difference is burning is you spend, earning is you get in those points to your account. And this transaction will change the points in the account. Okay. Okay, that makes sense. So that's basically all the classes here. Yeah. That's the system. And let me see if there's any other thing I want to explain. Yeah, that's earning and burning. Yes. Okay. And there's another thing called this earning transaction, service, loyalty, customer membership. That's fine. Oh yeah, there's another one called service level. So what does that mean? It basically means you are like a silver membership or golden membership, right? So it's with golden membership, you may get free tickets, or you may pay for a business class with the main cabin price, yeah, which is too good to be true. And you may purchase any item in the gas station with discount, but something like that. But it's controlled by the service level. Okay. Yes. So when you have this transaction, basically, it's generated by this service. And service take the information of the service level, and the service level will take the information from the membership. Then it generates transaction and update this loyalty account. So when you are doing updating to the loyalty account, those transactions, generate those transactions, the level is taken into consideration. So that's the service level, what the service level did. Okay. Yeah. Is introduced to this model. Okay. All right. So basically, that's what I want to mention about this system. Yeah, this system. Okay. So about all the information I mentioned, there are actually a lot of things which appears here, like the relation between each of them. One customer can have a lot of card, but a card can only belong to one customer. That's something clearly specified here, but too much information missing here. Like what I mentioned, how do you control the service level? So from what point can you upgrade from silver to gold member? Like we just, for example, we set up a condition like, okay, when you spend $1,000 within a year, then you should be able to upgrade to service level. That is something we cannot specify with merely the class diagram, okay? But that is something we can do with the OCL, right? Now let's take a look at how can we use the OCL to extend this system, okay? And there, more information missing than what I just specified, all right? Let's see, how can we do that? Adding extra information to it. Okay, so we were we were using those precondition, postcondition, and this invariance. And there are some other things here I want you to be aware of. For example, this. For instance, if we want to say a loyalty account will always be, let me pull this out, sorry. This rule here, this information, a loyalty account will always be initialized with 0 points, and the customer card will always be valid at the moment it is issued. Okay, for this kind of information, it may appear in the specification, right? Because the customer told you, okay, when we give a new card to a customer, we want the value to be 0, and we want card to be valid, right? So the account initial value is 0. So that's something called initial value. Okay, with initial value, it is not invariant. We should not use like, okay, maybe you're thinking about loyalty account. The context is loyalty account. Context is loyalty account. So if we want to say something like inside this loyalty account, the points is the initial value of the points should be 0. Okay, that is something we cannot do with invariance. We cannot do that because invariance means we have to hold that condition no matter under what kind of situation. It has to be true from the starting to the end of this system. Okay, that's something called invariant. Okay, like a pilot is a member, is a crew member. This should be true throughout the whole system from the beginning to the end. However, if we're trying to initial some value, if we're trying to initial that value with some value, initial variable with a value, it's true just when it starts, but it's not true when we are like doing the transaction update account, right? So we cannot just use invariant. So let me introduce another thing. It's called initial. It's called init. Okay. INIT. You use that to initial this value. Okay. So, but the context now we are not using loyalty program, but we are going to be more specific. If we are using the initial value here, we're directly following a value. Okay, 0. And what we want to do is we want to put the loyalty account points. Okay, let's go back here. For the loyalty account, we have a points attribute. We want to specify that to be 0. Okay, 0. All right. So that's how we specify an initial value to these points. Remember, it's not inv anymore, it's init, the initial. Okay. And another thing is we want to specify a customer card will always be valid at the moment it is issued. Okay, let's see. How do we do that? It's similar. Custom card will always be true. Custom card will be valid whenever it is issued. We're also using initial value. And how do we do that? Based on this diagram. Give me an answer. Someone volunteer. The question is the custom card will be valid when it's issued to a new customer. That means we want the initial value of the custom card to be true. What is that value? What's that? 0? No, variable. Some variable to be true. Some variable of the customer card to be true when it's issued. Let's see, what variables does this customer card have? Valid from, good through, color, name, right? What can be true? Yeah, there's only one Boolean type value there, valid. Okay, so we want the initial value of the valid to be true. Yes, correct. So the context becomes, yes, exactly, customer card. And
it's the initial value should be.
yeah, so we're using context and init. Remember, I'm telling you something has to be true.
So valid has to be true.
Yeah, so here we need this to reach the valid. Okay. So that's how we specify the initial value of the points and the initial value of the valid. Right. So this is how we extend this class diagram. Right. So we put this specification maybe somewhere under the class diagram together with the class diagram, and then those two information will be conveyed to the other stakeholders, whomever read this specification. It can be person or computer. Okay. Okay. And this is how we do the initial value. And sometimes we have derived attributes and derived associations. Okay, something like those Mr. and Mrs. This title is derived from the gender. You remember what we did last time, right? Yeah. So now we are using derived. Like if it's a female, we put the title as Miss. If it's male, we put the title as Mr. Right? So that's called the derived value. Derived value. Okay. So here let's define something. Custom card. Okay. Let's look at this class diagram. Let's look at this customer card. Okay. So here we have a printed name string, the last attribute, the last variable, printed name of the type string. Okay, you see that? See that? So is this one? Okay. So we want that to be a derived type because the printed name can be Mr. blah 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 or Mrs. blah blah blah. Because if you have a card, you take your credit card, it has a Mr. or Miss there most of the time, right?
Is that what that backspace value? That stand for garage?
Yeah.
Okay.
So yeah, here, but we need to specify this here. Okay, so let's give a context.
Can be
Context.
from the customer.
Yeah, customer card. See, that class is called customer card, right? And customer doesn't have the printed name because you do not print. It's only on the card you print this. Yeah,
Okay.
if you take out your credit card, I think they has. Okay, some of them only have name, don't have a Mr. and Mrs. Okay, but context is customer card. Is the printed name of the customer card. Okay, and because it's a derived, we use this keywords. Derive. Okay. So derive. We do not do this. We can just do this. It's the same. It's the same. Okay, derive, and I guess it's not case sensitive because I see different. Yeah, it's in a book, different place. Sometimes it's using the capital for the first context C, but I don't think that's case sensitive, so we can just do this. Okay, maybe I want to make it consistent. Okay. Alright, so following the derive, it should be a value. It should be the value for this printed name. Okay, so what do we do? Let me write it out. Owner dot title dot concat space, and then concat owner.name. Okay, so 3 parts here. One is this owner.title. Let's see, what is the owner? If you see, we are in the context of customer card, remember? So the owner of the customer card, if you see this keywords here, owner, right? You see that? That's like the R1, R2, R3 thing. So if we say owner, customer card owner, the owner refers to the customer. Customer has attributes called title. Basically, it's Mr. or Mrs. or Miss, something like that. Okay. So if we're in this, so then when we do owner dot title, basically, this is first part of the print name. It's Mr. or Mrs. Then it follows this space, concat with a space. Then it follows the owner's name. So like Mr. space Chao, blah blah blah, things like that. Okay, something like that. Alright, so that's how we specify this derived value. Any question on this part before I proceed to next? Yeah, if you have a question, feel free to ask. Concat is a method of the string to connect different strings. So it's, yeah, I believe it's specified here. Okay, so here, standard operation for the string type. String is a basic type for the OCL. Okay, so it has the concat sides to lower to upper, this operations. Just like when you're using some Java, it has this in there. The OCL is not Java, but it also has this defined. So concat. So this the whole thing is a value of string. So after the derive is actually we directly specify the value for this. Alright, so that's how we use this derive. We don't do like printed name equal to, that's not how we're doing this derive. Okay, actually this we can do something similar, like we just use context customer card, and then we can do invariant self dot printed name equals to this. Equal to self dot owner dot title concat blah 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 blah. This is the way we treat this as invariant. Okay, this can be invariant, that's fine, but we are learning how can we use this derived keyword. Derived keyword is direct following the value. Okay, so these two are the same for this system. For this system, this two specification is the same. All right, they are the same. They have the same meaning. Okay. All right. Next is we can define operations for the system as well. One of the type of the operation is called query operations, which doesn't change the state of the system. It's just like we check how many males or females in the system, how many like query. We check the data. Okay, it's like query. Do not change any system state. And for instance here we want to suppose the class loyalty program. Look at that class, loyalty program, has a query operation get service, which returns all service offered by all program partners in the program. Okay, we see there's a get service there. Can you see that? So in the loyalty program, the second method, the second operation is get service. Okay, and the type returned by get service is a set of services. Okay, it's not set, it's not get set, it's set of services after this here, this part, get services. This return the set of services. Okay, so in this class diagram we only have the type, the name of this operation. Okay, so this operation is kind of query operation. We can specify query operation with OCL as well. And let's see how can we do that. Then we need to introduce another keyword. It's called body. Okay, so right now what we want to specify, remember what we want to specify is the get service will return all the service offered by all the program partners in the program. Okay, that's what we want to specify. Because we mentioned we have in one of the loyalty program we have a lot of partners, and partners have a lot of services. Okay. So here the context become the loyalty program get services set of service. Okay, and then we use another keyword called body to specify this query. So how can we do that? It's basically it's a partners dot delivered services delivered services. Okay, so we are trying to say what is this get service, and we're using partner.deliver service. What is partner? Let's see. Let's go to this loyalty program class diagram. Look at the loyalty program. Okay, and then we find here this is partners, right? The association between loyalty program and the program partner is partners. It's called partners. Okay, so when we are saying under this loyalty program context, if we are saying per partners, then we are actually having a set of program partner. Okay, and a program partner has, if we're saying program partner dot deliver services, it's basically this association. Associate the program partner to the services. It's one to many, right? One to many. Like all the services provided by a program partner. Okay, so like a service, it's one to many because like Delta can offer you a lot of services, but Delta service can only be provided to you by Delta, not Southwest, not gas station. Okay, make sense? So the service is one to many. Then if we are partners dot delivered service will return you a whole set of service. So basically here is partner dot delivered service, like partners dot delivered services here. Okay, will return you this whole service thing. That's exactly what we want to specify. So the loyalty program get service function will return you the partner.services. Partner is a set. Partner.services is another set. Okay, we have 10 partners, and each partner has a lot of services, and this will give you all the services as a set. Okay, so this is a query. We want to check that part. All right, and okay, we can do the last one. So in the body expression, the parameter of the operation may be used. Yeah, we can use the parameter. For instance, suppose you need a more refined version of get service operation. This operation takes the parameter, a program partner object, and returns the service deliver a program. Okay, suppose now we are okay, forget about this thing. Now we want to specify this get service again, but this time, okay, the context is the same. Context is the same. But this time the get service is different. It basically not returning you all the services provided by all the program partners. It only returns you a service, say provided by Delta, or it only returns you a service provided by a gas station. Okay, then we need a parameter to specify which partner service do we want. Okay, so here we will need this parameter of program partner. Okay, then here this body is gonna be, we're using this if statement. If partners includes Okay, so we've mentioned this logic. We can use if, then, else, and if. Okay, so this is something easy to understand. This part is understandable. Okay, so this basically specifies, okay, if we are getting a service provided by PP, which is a program partner, maybe it's Delta. Okay, which the PP is, maybe let's say it's Delta. Okay, then the body means we specify, okay, what should this operation do? Should this get service operation do? Is it will return. So we have condition. If the partner includes, say, Delta, then we return Delta dot delivered service. Delta is the program partner, right? Here, let's go back to the class diagram. Program partner dot delivered service is a service. Okay, so all the service is provided only by Delta, only by one of the program partner. All right, so we specified it this way. So if it's included, if Delta is in this program, then we return the services by Delta. If it's not included, it's else, we return an empty set. So that's all it wants to specify. All right. Okay. Go back, and when we go home, go back and read all the specifications. Yeah, it may be a little bit confusing if it's especially it's the first time you look at this. So what are you trying to specify? Okay, basically we're only two things today. One is we want to specify an initial value of some attributes. Okay, and the initial value is 0 or true, something like that. Or we can assign a string to a string attributes as well. Okay, and also we can use the derived value to assign such kind of value. We assign the value. All right. The other thing is we specify what is that operation do. All right, like the get service. One way we specify it as a get all the service. Another way is we specify it as a get service from some certain company. But obviously, if we are doing that, we need a parameter, like which company. Okay. All right. So that's all for today. So please go back and read all those examples. Figure out what exactly that means. Okay.